Welcome to a deep dive that's custom tailored just for you. Our mission here is really to give you a shortcut to being truly well informed.
Yeah, extracting the most important nuggets of knowledge and insight.
Exactly, with just enough humor, hopefully, to keep you hooked.
Today, we're plunging into the fundamental concepts of chemistry, as brilliantly laid out in Chemistry, an introduction to general, organic, and biological chemistry. It's the 13th edition by Karen Timberlake.
A classic textbook, but it sounds like much more.
It really is. It covers a lot.
That's right. So we're going to unpack the core ideas this text aims to teach. Everything from, the tiny building blocks of matter to the incredibly complex biochemical processes happening inside our bodies, like right now.
Constantly.
And we're going to consistently highlight how incredibly relevant it all is to health and life sciences.
Definitely.
So think of this deep dive as your essential guide. It's about understanding the chemistry that literally surrounds and defines our world, especially if you're thinking about or already in a health-related profession.
A really crucial foundation.
So let's unpack this. The book wisely starts by laying down the groundwork. It makes it clear right away that chemistry isn't some abstract thing stuck in a lab.
No white coats required for everyday chemistry. It's happening all around us all the time.
Yeah.
What's truly fascinating, I think, is how the author just demystifies the words themselves. She defines chemistry simply as, well, the study of matter.
No.
Its composition, structure, properties, how it reacts. And chemicals, they're just substances with a consistent makeup and properties.
Just basically everything. Coffee, shampoo.
Exactly. The air you breathe, it's all chemicals. It really strips away that, intimidating feeling, doesn't
Yeah,
it?
absolutely does. And after grounding us in what chemistry is, the text quickly introduces the scientific method.
Ah, yes, the logical thinking process.
Right, that structured way of thinking that's not just for scientists, but really for, well, everyday problem solving too.
Indeed. It's about systematically figuring things out. The book outlines it clearly.
Mm-hmm.
You start with observations.
Seeing something happen.
Right. Then you form a testable hypothesis,
Mm-hmm.
an educated guess you can actually check.
Okay.
Then you design experiments to test that hypothesis and finally reach a conclusion or maybe even develop a scientific theory.
Makes sense.
And to make it super relatable, Timberlake uses this simple, almost funny example. Imagine you're sneezing like crazy at a friend's house.
Okay, happens.
Your brain might go, aha,
Mm.
must be the cat. That's your hypothesis. The experiment is seeing if you stop sneezing when you leave or start again near another cat. It shows how that same logic applies to everything from, developing medicines to figuring out why your phone battery drains so fast.
I love that. It also emphasizes critical math skills right from the start, which honestly can be a hurdle for some.
It really can be. But the book tackles it head on.
You might think chemistry is just memorizing stuff, but the book immediately says, look, practical math is the language here.
Absolutely. And the text doesn't just assume you know it all. It actually reviews essential key math skills. Things like place values, positive and negative numbers, percentages, solving equations, reading graphs.
The basics, but the crucial basics.
Totally. These aren't just like abstract exercises. They are the tools you'll use constantly. Measuring medications, interpreting lab results, calculating dosages.
Precision is key in healthcare.
Exactly. And math is how you get there.
And what's really compelling about this textbook, I think, is how these early foundational concepts get immediately connected to the real world. It gives you the why right away.
Precisely. For instance, Chapter 1 ties basic chemistry directly to forensic science.
Oh, cool.
Yeah, showing how analysts look for toxic compounds like, say, ethylene glycol and antifreeze in poisoning cases. It also explains how hemoglobin, that protein in our blood, carries oxygen.
Stuff happening inside us.
Then, Chapter 2, Chemistry and Measurements, it spotlights the vital role of a registered nurse and the absolute need for precise measurements. Think about administering meds or monitoring blood volume.
Can't mess that up.
Not at all. Even subtle things like changes in bone density for diagnosing osteoporosis, that relies on accurate measurement.
Then we see how understanding matter and energy in Chapter 3 connects directly to the work of a dietitian.
Right. It gets into the chemistry behind diet and exercise for weight management, looking at the actual energy values in food. Super practical if you're interested in nutrition.
Definitely.
And Chapter 4, on atoms and elements, takes us right down to the building blocks. It doesn't just list elements. It points out the ones essential for health, iron for blood, calcium for bones,
And the flip side, too, like toxicity.
Yeah, it tackles critical issues like mercury toxicity, linking to environmental health. It even shows how understanding elements helps a farmer improve crop production.
Wow, so it really shows how fundamental chemistry connects to, well, everything. Our lives, our health, the planet.
It's a powerful illustration for sure.
Okay, this is where it gets really interesting, I think. Once we understand the atoms, the book dives into how they interact, how they form everything around us.
Yeah, this is the nuts and bolts of how matter actually behaves. The textbook moves into ionic and molecular compounds.
Okay, bonding.
Right. It's all about how atoms bond. It explains the two main ways. Either electrons are completely transferred, that gives you ionic bonds, like in table salt.
Sodium chloride.
Exactly. Or electrons are shared, forming molecular bonds, like in water H2O. The text guides you through naming these compounds, drawing their structures, Lewis structures, specifically, and even predicting their shapes, using concepts like electronegativity.
And the payoff. Why does this matter for health?
Well, it highlights how crucial certain ions are in your body. Think sodium, potassium, chloride. Like, these ions are constantly moving across your cell membranes, driving nerve impulses, keeping fluids balanced. It's chemistry happening inside you right now.
Okay, that makes sense. Then we hit nuclear chemistry. That sounds intense.
It often sounds intimidating, yeah, like something out of science fiction. But the book really focuses on its fascinating and incredibly positive medical uses. It's not just bombs, it's about healing.
Good to know.
Right. It explains natural radioactivity, how unstable atoms decay, and how we measure radiation. It introduces half-life, the time it takes for half a sample to decay.
Which is used for dating old things.
Yeah, like artifacts.
Yep.
But crucially for health, it dives into radioisotopes. These are specific radioactive atoms doctors can track in the body. For instance, thallium-201 helps visualize blood flow to the heart in cardiac imaging.
Wow.
It also covers things like brachytherapy, placing tiny radioactive sources inside the body to target cancer directly, or even how we detect radon gas, which is naturally radioactive, in homes to prevent lung cancer.
So, really important applications. From the atom's core, the book builds to chemical quantities and reactions. This sounds like the recipe part of chemistry.
That's a great way to put it. It's essential for knowing how much stuff you need for a reaction or how much product you'll get.
Okay.
This chapter introduces the mole concept. Now, this sounds kind of weird, but think of it like, well, like a chemist's dozen.
Okay, so a way to count huge numbers of tiny things.
Exactly. It lets us group atoms or molecules so we can actually measure them out, for reactions. It allows us to balance chemical equations, knowing what goes in and what comes out.
And the health links.
Oh, definitely. It connects to critical stuff like carbon monoxide toxicity, how it blocks oxygen transport. And it even explains the simple chemistry behind those instant cold and hot packs for injuries.
Ah, those. Okay.
It's all about controlled chemical reactions.
Gases and solutions also get their own sections. Super important for how our bodies work, right? Breathing, kidneys.
Absolutely crucial. The gases chapter covers fundamental laws like Boyle's law, pressure and volume being inversely related.
And that relates to breathing. How?
The book connects it directly to how your lungs expand and contract. Same principle explains why divers get the bends, or how hyperbaric chambers treat conditions like exercise-induced asthma by increasing oxygen pressure.
Huh. And solutions.
That chapter delves into electrolytes in body fluids, sodium, potassium, calcium again. They conduct electricity, vital for nerves and muscles. It talks about solubility, linking it to gout and kidney stones.
Oh, great.
And it explains the vital role of osmosis and dialysis for treating kidney failure. Truly life-saving chemistry.
And finally, a real cornerstone. Acids and bases and equilibrium. This seems fundamental to our internal balance.
It's absolutely critical. The chapter explains pH, that scale of acidity and basicity, and the concept of buffers.
Buffers?
Yeah, chemical systems that resist pH changes. The book makes it really tangible, talking about stomach acid and how antacids work. But more profoundly, it highlights the buffer systems in our blood plasma.
Keeping our blood pH stable.
Exactly. They constantly work to prevent dangerous conditions like respiratory acidosis or alkalosis. Our bodies are amazing at self-regulating, and these chemical equilibria are key to maintaining that delicate balance for health.
Okay, now for the really deep dive into the chemistry of life itself. We're talking organic chemistry, the chemistry of carbon compounds, the backbone of life.
Exactly. This is where you see how those basic building blocks assemble into us, basically. Chapter 11 introduces hydrocarbons, molecules made just of carbon and hydrogen.
Like fuels.
Often, yes. But it compares organic, carbon-based, and inorganic compounds, details structures like alkanes, aromatics. But here's a mind-blowing bit. cis-trans isomers.
Okay, what are those?
They're molecules with the same atoms but a different spatial arrangement, like a specific bend. The book explains that a tiny flip, a cis-trans change in a molecule called retinol, is essential for your night vision.
Wow, really? Just a bend?
A single bond flip lets your eye detect light. Tiny chemistry, massive biological impact. It also links to things like pheromones and infects and hydrogenation of fats.
That's incredible. Then it branches out into more complex functional groups, right? These give molecules their specific jobs.
Precisely. Chapters 12 and 14 explore alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, lemons, amides. Sounds like a mouthful.
It does.
But these are the building blocks of so many biological molecules and medicines. The book gives relatable examples. Hand sanitizers are alcohols. It explains how our bodies process alcohol. Salicylic acid, the basis for aspirin, came from willow trees.
Ah, nature's chemistry.
Right. And it covers how amines and amides are crucial in painkillers, antidepressants. Understanding these groups unlocks how drugs work.
And then the grand tour of the biomolecules themselves, the big ones?
Yes. Chapter 13 hits carbohydrates, sugars, starches. It explores their types, dives into chiral molecules, mirror image molecules.
Why does that matter?
It's profound. It affects how our bodies process sugars, regulate blood glucose, even determines blood types. Small difference, big consequences.
Yeah.
Then chapter 15 covers lipids, fats, and oils.
Omega-3s.
Yep, fatty acids like those. Also triglycerides, our main energy storage. And phospholipids, fundamental to every cell membrane. Super important in conditions like infant respiratory distress syndrome. It also covers steroids like cholesterol, essential but tricky, and touches on anabolic steroids, genetic conditions like high cholesterol, and gallstones.
Proteins and enzymes are next. The body's workhorses, you said.
Absolutely. Foundational to almost everything. Chapter 16, Amino acids, proteins, and enzymes is key. It details amino acids, the building blocks.
Right.
How they link via peptide bonds. Explains the 4 levels of protein structure from a string to complex 3D shapes, and how enzymes act as catalysts, speeding up reactions.
And connects this to diseases.
Vividly. Sickle cell anemia, one tiny amino acid change deforms hemoglobin. Alzheimer's disease linked to misfolded proteins. It really drives home how critical a protein shape is.
And then the blueprint, nucleic acids, DNA and RNA.
The ultimate code. Chapter 17, Nucleic acids and protein synthesis, explains DNA, RNA, how DNA copies itself, replication, how info goes from DNA to RNA transcription, then to proteins translation.
The central dogma.
Pretty much. It covers genetic mutations, recombinant DNA tech, how viruses work, and highlights applications like understanding BRCA genes in breast cancer, or how antibiotics stop bacteria by blocking protein synthesis.
Clever. Finally, the energy engines, metabolic pathways, how we turn food into fuel.
Chapter 18, Metabolic Pathways and ATP Production, rounds it out. It explores how we break down carbs, fats, proteins for energy, processes like glycolysis, the citric acid cycle, electron transport.
That sounds complicated.
It is intricate, but the book connects these cycles to everyday health. Lactose intolerance, stored fat and obesity, ketone bodies and diabetes, even treatments for things like hepatitis C. It shows the chemistry behind energy and health.
So taking a step back, what does this all mean for someone learning from this book? It's clear the author, Karen Timberlake, really thought about the student experience.
Yeah, that's a great point. Beyond just what it teaches, how does the text make this dense subject, well, approachable and engaging?
Well, for starters, it uses these chapter openers with clinical stories, draws you right in. And clinical updates show the follow-up, so you're always seeing the why in real patient settings.
That context is huge. And those chemistry linked to health and chemistry linked to the environment boxes are woven throughout, right?
Exactly. They're not just side notes. They actively apply concepts to things like weight loss, blood buffers, kidney dialysis, constantly reinforcing the relevance.
Showing you it's not just theory, it's life.
And for tackling problems, which can be daunting, it offers really clear step-by-step help.
That's crucial. The try it first feature pushes you to actively solve it before seeing the answer. Builds critical thinking.
Right. And the analyze the problem boxes.
Yeah, those break questions down into given, need, connect, like a roadmap, plus a solution guide. It teaches you how to think through problems, not just memorize answers.
It really leans into active learning, doesn't it? It's not just passive reading.
Absolutely. The little engage prompts in the margin for quick self-tests, the constant practice problems, study checks, it's all designed to reinforce understanding.
And it even gives study advice.
Yeah, like forming study groups, avoiding cramming.
Mhm.
It emphasizes retesting yourself, connecting new ideas to old ones. Basic learning science, really, but vital for making it stick long term.
And the visuals. Chemistry can be so
The
abstract.
visuals sound incredibly helpful, especially the macro to micro illustrations. Seeing an everyday object, then zooming right down to its atoms and molecules, that makes the unseen tangible.
That sounds really useful.
Definitely. And there are suggestions for interactive videos, too, in the online resources. It's a whole package, really, aimed at making chemistry stick and ensuring you get a deep, usable understanding.
This deep dive really highlights how this book, Chemistry, an introduction to general organic and biological chemistry, it isn't just another textbook. It feels more like a comprehensive, student-focused guide.
Yeah, designed to equip you with essential chemical knowledge, but maybe more importantly, show you its profound impact on health and life sciences.
Understanding these principles from, simple atoms all the way up to complex metabolic pathways, it gives such an invaluable framework.
Absolutely. For anyone going into health, environmental fields, or frankly, anyone just wanting to understand their world and their own body better, it really is the language of life and health.
So maybe a final thought for you listening.
Yep.
What new chemical interaction will you look for in your daily life now? Maybe you'll think about buffers when you take an antacid or cis-trans isomers next time you're out at dusk.
Yeah, look around. We hope this deep dive has been illuminating and maybe given you a clearer, more fascinating path to being truly well-informed.
A warm thank you from the Last Minute Lecture team.